Let's talk about solving systems of linear equations by row reduction when there are more variables than equations. What happens when you have more variables than equations? For example, let's solve w plus x plus y plus z equals 10, w plus 2x minus y plus z equals 6, and w plus 2y minus z equals 3. As before, the aim is to get the matrix in row echelon form, or really what we want here when there are more variables than equations, we really want to get it in reduced row echelon form. Using elementary row operations. There's our matrix, augmented matrix. Again, we want to use this one up here to kill off all the ones below it. So we'll add the opposite of row 1 to row 2. That's what the opposite of row 1 looks like. -1, -1, -1, -1, -10. Add that to row 2. 1 plus -1 is 0. 2 minus 1 is 1. -1 plus -1 is -2. 1 plus -1 is 0. And 6 minus 10, that's -4. So here's what row 2 is going to look like. 0, 1, -2, 0, -4. Now, let's use row 1 to kill off. This one here. So we're going to use this one to kill off this one. We'll add the opposite of row 1 to row 3. Again, we know what the opposite of row 1 looks like. When you add that to row 3, you end up with 0, -1, 1, -2, -7. Good. So we've dealt with the first column. Now let's deal with the second column. We're going to use this leading one to kill off all the ones below it, or all the entries below it. So let's add row 2 to row 3. When we do that, well, here's row 2, as if you need to be reminded of what row 2 looks like. When we add row 2 to row 3 will then look like this. 0, 0, -1, -2, -11. Oh, we are almost in row echelon form. We don't like this -1. We multiply it by -1. And we end up with 0, 0, 1, 2, 11 as the bottom row, third row. Okay, this matrix is now in row echelon form. We're not done yet, though. We really want it to be in reduced row echelon form. So let's use this one to kill off the entries above it. We're going to use it to kill off that 2. So multiply row 3 by 2 and add it to row 3, or add it to row 2. This is row 3 multiplied by 2, 0, 0, 2, 4, 22. Add that to row 2, and notice what we'll end up with. Okay, you can do the math. So you got 0 plus 0, 0 plus 1, 2 plus -2, 4 plus 0, 22 minus 4, etc. This is what we'll end up with. Row 2 will then look like this. 0, 1, 0, 4, 18. That's our matrix. And now, let's use this one to kill off this one. So we'll add the opposite of row 3 to row 1. Here's what the opposite of row 3 looks like. Add that to row 1, and row 1 becomes 1, 1, 0, -1, -1. Great, we're almost there. Now let's use, again, we've dealt with this column. That's just dandy. Now let's use this one to kill off the one that's above it. We'll multiply row 2 by -1 and add it to row 1. Here's what the opposite of row 2 looks like. Add that to row 1. And we end up with this, 1, 0, 0, -5, -19. This is in reduced row echelon form. So now we can see what the solution looks like. A w minus 5z equals -19, x plus 4z equals 18, y plus 2z equals 11. Now, what we usually do at this stage is get the leading variables on one side of the equation and everything else, including constants and free variables, on the other side of the equation. You'll see that notation in a moment, that vocabulary in a moment. There are infinitely many solutions. You can plug in any value of z and get a solution. Z is called a free variable. The other variables, w, x, and y, are leading variables. We can distinguish the leading variables and free variables by looking at the row echelon or reduced row echelon form. The first non-zero entry in a row is a leading 1. A variable with a leading 1 in its column is a leading variable. Okay, so there's a leading variable, there's a leading variable, there's a leading variable. The other variables are free variables. So in other words, w, x, and y are leading variables, and the other variable, namely z, that's a free variable. So again, here are the rules about getting a matrix into row echelon form using elementary row operations.